For 12.5, we're going to work with chords, segments, and secants for in a circle. So the first part, we're going to talk about segments of chords. So if we have two chords that intersect inside of a circle, and remember, chords stop at the edge of the circle. They don't continue on outside of the circle. If we take the two parts and multiply them together for each part of the chord, they're going to be equal to the parts of the second chord multiplied together. So for this one, if we take EA and multiply that by EB, that is going to be equal to DE, or ED, multiplied by EC. So the way that we can remember that is anytime you have two chords, you're going to take part times part and put that equal to the part times part of the second chord. And you're going to want to remember this because there are a couple of problems like this on the test. So if we look at our first example, and the two parts that are on the same side come from the same chord. So if we look at one of our chords, LM, one part is x plus 3 and the second part is x plus 1. So we're going to multiply those together. Because they have more than one term, we're going to put them in parentheses. And then our second chord, JK, is split up into two parts that we're also going to multiply together. When you have two sets of parentheses, don't forget you are going to need to FOIL. So we're going to get x squared plus x plus 3x plus 3. And we can combine like terms to get 4x. On the right side, because there's only one term in the second part, we're just going to multiply that by both terms inside the parentheses. So we would end up with an x squared plus 5. With this problem, sometimes you will have to factor, other times you are going to end up with the same term on both sides, like this, where we have an x squared. So if we were to subtract that, they're both going to disappear, and then we no longer have an x term to worry about. So then we would just have 4x plus 3 equals 5. And then we just have a linear equation that we are going to be solving. And then when we divide by 4, we're going to end up with the answer of x equals 1/2. When you are doing these problems, it's important that you read the question. So they want us to find the length of ML and JK. So in this, if we look at our picture, ML is equal to x plus 3 plus the second part of x plus 1. And we know that both x's are equal to 1/2. So we're going to have 1/2 plus 3 plus 1/2 plus 1. So that's going to equal 1, 2, 3, 4, 5 for our final answer for ML. Then we'll do the same thing for JK. We're going to plug in our x value of 1/2 plus 5 plus another 1/2. And for these, 1/2 plus 1/2 is 1, plus 5 is 6. And that would be our final answer. Okay, so if you want to pause the video and try part B on your own, you can, or you can just follow along as I go through it. So for this one, again, we're going to take part times part of the same chord. So we're going to have x plus 2 times x plus 1. And then part times part on our second chord. So x times x plus 4. Don't forget to FOIL, so you would get your x squared plus x plus 2x plus 2. So on both sides, we ended up with an x squared, so we can just get rid of that right away. And then we can also combine in any like terms we have. So we're going to have 3x plus 2 equals 4x. And then the fastest way to solve this one would be subtracting 3x on both sides to get x equal to 2. And don't forget, once we have that, we need to answer the question, and they want the length of ML and JK. So ML had two parts where we had x plus 2 and x plus 1. So we're going to add them all together. And all of the x's get replaced with a 1. So we're going to have 2, 4, 6, 7 for our final answer of ML. Then for JK, we have x plus and x plus 4. And again, because x is equal to 2, we're just going to replace the x's with a 2 and then add them up, and that gives us our final answer of 8. Okay. Our next part that we are going to be going over today is when we have segments of a secant. So a secant is a part of a segment that goes outside of the circle. So this one is going to have an ending where it ends at the edge of the circle. So anytime you have a secant like this, we are going to take the part that's on the outside of the circle, and we're going to multiply that by the whole length of that secant of the circle. And when we do that, it is going to be equal to the part on the outside of the circle on the other secant multiplied by the whole. So we're going to have part times whole equals part times whole. So if we use an example for number 2, if we look at the secant that's on the top, the part that's on the outside is 6, and then the whole thing, you have to make sure you are adding. So we have to take 9 plus 6, and that would be 15. And then that is going to be equal to the part on the outside on our second secant multiplied by the whole thing. And again, you have to do the adding, otherwise your answer is going to be wrong. Okay, so then we're going to distribute and do some multiplying. So that'd be 60, 90, and then equals 5x plus 25. So we'll start by subtracting that 25 on both sides. And then dividing by 5. And that will give us our answer of x equals 13. And this one was just asking us to find the value of x, so that would be our final answer. Then if we look at part B, this one's going back to our two chords. So again, because it's two chords that meet in the circle, we're going to take the two parts and multiply them together. So part times part equals part times part. And then we solve for our variable. And in this one, it ends up being 8 for our final answer. So the difference between A and B is that A, this one, the two secants met outside of the circle. And in B, the two chords met inside the circle. So that's how you can tell the difference between those two types of problems. Looking at C, because this one meets outside the circle, that's where we're going to take part times whole again. And the part that we're working with is the part outside of the circle. So we're going to take 3 times, and then we have to add both of these pieces together. So it might be easier if you combine like terms before you plug it in. So we're going to combine them to be x plus 5. And then again, our part outside of the circle, so x plus 1 times, and then we have to add these two together. So if we look, there are 2 x's, and then we have a plus 1 and a minus 1. So those cancel out to equal 0. So we don't even need that part. We're just going to keep the 2x. Once you get here, don't forget to distribute. Now, when you get to a problem that looks like this, and you have an x squared that's not going to disappear, then you are going to have to either factor or use quadratic formula. So when we do that, we need all of our terms to be on the same side of the equal sign. So I am going to move everything over to the right side, and we're going to have 0 equals 2x squared minus x minus 15. And you can either factor or use the quadratic formula. I'm going to use the quadratic formula here because that's what most people do. So remember, the quadratic formula is negative b. Because our b value is already negative, that means we're going to have two negatives there, plus or minus the square root. And again, because our b value is negative, we're going to put it in parentheses when we square it. And then you subtract 4 times our a value of 2 times our c value of negative 15. All over 2a, or in this case, 2 times 2. So remember, to get your two different answers, you are going to take it where you add the square root and then where you subtract. And I always recommend doing the top part separate from the bottom. So these two negatives are going to make it positive. So we're going to have 1 plus the square root of negative 1 squared minus 4 times 2 times negative 15. So that one, we're going to end up with 12 over 4, which simplifies to 3. And then we're going to do the same thing, except we're going to subtract the square root instead of adding it. And that one gives us negative 10 over 4. And you can give your answer as a decimal or a simplified fraction. So this one would be negative 5 over 2 as a fraction. Awesome. So again, on the test, there is going to be a problem where you have to either use the quadratic formula or factor. So if you have questions on those, make sure you are asking. Okay. So then the last part of today's is the segments of secants and tangents theorem. So for this one, when you have a tangent, you are going to take that one and square it, and that's going to be equal to the part of the secant that's outside of the circle, just like before, multiplied by the whole length of the secant. If you feel like you're not going to remember that, but you are comfortable with this previous, where we take part times whole, you can still use that. So if you look, we can use the part of the tangent that's outside of the circle, and then we would multiply that by the whole part. You'll just notice that those two are the same measurement. So that's where the squared comes from. And then on the secant part, we just use part times whole like we were before. So you can remember as a tangent squared, or you can still use the part times whole. Okay, so let's do a couple examples with this one. All right, so we're going to use the circle to calculate the value of x. So if we look, we have a tangent. So we're going to take the part that's outside the circle, multiply it by the whole length. So if we look, the part is equal to 16, and the whole length of that segment is also 16. And then that's going to be equal to part times whole for the secant. The part on the outside is x, and then the whole thing is going to be x plus 8. So again, we're going to go ahead and solve. I'm going to pull up my calculator really quick. So 16 times 16, or 16 squared, is 256. Equals, and then we have to distribute. So we're going to have x squared plus 8x. Because the x squared is not going to disappear, we're going to get everything to the same side of the equal sign. So we have 0 equals x squared plus 8x minus 256. All right, so for this one, I'm going to factor. So I know it's going to factor into two sets of parentheses. Because the first term is just an x squared, that means they're both going to be x's. And because it multiplies to be a negative value, one of these numbers is positive and the other one is negative. So we just need to figure out two numbers that multiply to be 256 and add or subtract to be 8. Let's try. Let's see, we know 8 goes into it. And 1624 is a decimal. 32 and 8, nope. Let's see. Let's do. You know what? I can't think of it right now, so I'm just going to use the quadratic formula. So for that, we're going to have x equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 256. And that's going to be all over 2 times 1. And we're going to add once and then subtract to get our answer. All right, so negative 8 plus the square root, 8 squared minus 4 times 1 times negative 256. That would be why, because it's not going to be a nice number. All right, so then we have to divide this answer by 2, and it's going to be about 12.5. Okay, so then if we just change it to subtracting, and then if we divide that answer by 2, we're going to get x is about negative 20.5, and that would be our two different answers. Okay, so sometimes you won't be able to factor, and you'll just have to use the quadratic formula. The one on the test or the quiz can be done either way, factoring or quadratic formula. Okay, so if we move on to our next example, again, we're going to take part times whole, so 15 times 15 equals the part outside, x, times the whole thing, which is x plus 14. So if we start by taking 15 times 15, that's going to give us 225 equals, and then we have to distribute to get x squared plus 14x. And we want one side to equal 0. And this one, let's see, I think this one can be factored. Let's divide this by 5. Perfect. So if we look, because this one starts with an x squared, that means each of the first parts in the parentheses is going to be an x. Because it multiplies to be a negative, that means we're adding one and then subtracting the other value. So two numbers that can multiply to be 225 are 25 and 9. And these two, if we were to subtract the 9, that's going to be, 9, it's going to be 16. So not quite those two. Let's try 225. 45 and 5. I don't think this one is actually going to be factorable either. All right, so I guess we're going to do quadratic formula. So if we can't find the ones that add up to that value, then we will again have to use the quadratic formula. So this one would be negative 14 plus or minus the square root of 14 squared minus 4 times 1 times negative 225 all over 2 times our a value. And we're going to add or subtract. And you want to make sure you're careful when you type it into your calculator so you don't accidentally get the wrong answer here. Yep, and this one is going to end up being a decimal as well. And we can't forget to divide our answer by 2. So the first one is going to be about 9.6. And then if we were to subtract the square root, we would get about negative 23.6. And that would be our second answer. Okay. If you want to try the last one on your own, you can. Or you can just follow along. So again, we're going to have part times whole on both sides. So we're going to have 12 times 12 equals x times, and don't forget to add these together, x plus 10. And then if we multiply and distribute, we're going to end up with x squared plus 10x on the right side. And we want one side to equal 0. And I don't know if we will be able to factor this one. 18 and 8. Ooh, this one we will be able to. So if we look, again, it multiplies to be x for our first term. So both of the parentheses are going to start with x. And they multiply to be a negative. So one's going to be plus, one's going to be minus. And 144 has two factors of 18 and 8. So those two can be added and subtracted to equal 10. So because they add to be a positive value, the bigger number has to be positive. So that would be a positive 18 and then a minus 8. So then that would give us what our factored answer is. Don't forget we need to figure out what x equals as well. So we're going to set both set of parentheses equal to 0, and then we would be able to get our final answer of x equals negative 18 and x equals 8. So we would get two answers. Now there's one thing we want to look at when we go back and look at all of these last three problems we've done. One of them, when it's talking about x, is talking about a segment. So because it's talking about a segment, the answer for x has to be positive. So if we look, this x squared equals negative 20.5, that is not going to be an answer because we cannot have a negative length. So then if we look at the next one, again, x is talking about a length, so the negative answer can't be one of our options. And same thing for this last one. We don't want a negative value to represent our length. So each of these, there's only one possible answer, even though there are two answers that fit the equation. So make sure you're paying close attention to that when you're answering your question.